Understanding normalization is absolutely fundamental to understanding why we're doing data warehousing and some of the design techniques that we'll need to look for both in our OLTP database and how we're going to move those over into the data warehouse. And now, I know it sounds like I'm kind of beating on a dead horse, but it's fundamental that you understand this. What is normalization? Well, now this is a topic you can go out and read on. It certainly wouldn't hurt you to go out and read on. This goes back to Dr. E.F. Codd's papers way back in the 70s about data organization and so forth. But really it comes down to the process of organizing the tables in a relational database and how the data is organized within those tables. And it's a design structure that has a simple goal of eliminating data redundancy. We don't want to store data twice in our database. And so it also helps lower record locking so that more people at once can use the database, and so therefore it's increasing the efficiency and concurrency. And the way that normalization is really accomplished, a very simple way to describe it is we just divide the large tables into smaller and smaller tables, and then we create relationships between those tables so that when we need to pull data from both tables, we can connect them back together. The best way to understand that is to see an example. Now, before normalization, let's say that we had a table, and all we wanted to keep in this table was the first and last name of our employees, the pay grade that they're currently working at, and the state in which their office is. Okay, so you can see from the data pretty easily here that Mark Long is pay grade 8, and he's in the state of Tennessee. Bob James is pay grade 10, he's in California. But notice Frank James is pay grade 6, he's in Texas, but Frank is an engineer and he also has an office in California as well. So Frank has 2 offices. Well, how do we handle that in this table except that we put in Frank James twice and we put in the pay grade twice? Well, there is a way that we can take care of this. We can normalize this table. All right? So we see that James has 2 offices. So let's see how we can get rid of this redundant data in our table by using normalization. Well, what we're going to do is we're going to split that table into 2 tables. And notice we've added a column. We've added a common column between the 2 tables called EID, Employee ID. And notice every person that gets added into this table that is unique, and there won't be any that aren't, every unique additional row to this table gets generated an EID for it. And we can't have duplicate EIDs. And so what we did is we put Frank James in here. He's EID 3. He's pay grade 6. And then over here in our related table, we put the states. And then notice Frank James is 3. He has 2 entries over here for 3, one in Texas, one in California. And so by creating a join on these tables, when we query this data, we can get everybody's states. Okay, I hope that makes sense to you. Because what we've done now is we've created a primary foreign key relationship between these 2 tables so we can join that data and give it meaning. And we can easily see here that James has offices in 2 states, but we haven't had to replicate data. We've replicated our key here, but our key, other than identifying the relationship between the tables, key being the EID column, right? We've replicated these, and we've even replicated it here. But this data really doesn't have any intrinsic meaning to our data. But it's a lot better to replicate this as opposed to actual data, Frank James and pay grade and so forth. Okay, that is in essence normalization. It's obviously going to get more complex than that. There's ways to work through it, and again, this is something to nerd out on a little bit if you're not really familiar or comfortable with it. Just go out there and grab some information off the internet about normalization and read about first, second, third, fourth, fifth normal form, and it'll start to click and make sense.